Hydrogen bond. Explain with examples the formation of a hydrogen bond. Explain the effect of the hydrogen bond on physical properties of substances. Alright, what is hydrogen bond means? Hydrogen bonds are attraction forces between hydrogen atom that has bonded with an atom of high electronegativity such as nitrogen, oxygen or fluorine with another oxygen, nitrogen or fluorine in another molecule. Okay, let we see the hydrogen bond among water molecules. How the hydrogen bond occur among the water molecules. So this is the water molecules H2O. Alright, so oxygen atom has high electronegativity, hence it attains a high negative charge. Okay, delta minus. So next, hydrogen atom attached directly to the high electronegative atom, causing hydrogen attains a high positive charge. So delta plus here. Next, and when another water molecule come closer, okay, so what will happen? The high electronegative atom will become slightly negative, while less electronegative atom will become slightly positive. This one, slightly positive, slightly negative. So next, attraction between hydrogen atom in a water molecule with oxygen atom from another water molecule. So the attraction between the oxygen of one water molecule and hydrogen from another water molecule, we call it as hydrogen bond. What is the role of hydrogen bond in our daily life? First, we see as in our textbook, it explains about why hair stick together when wet. Our hair has a protein molecules. Okay, when hair is wet, protein molecules no longer form hydrogen bonds among themselves. Instead, these protein molecules will form hydrogen bond with water molecules. It's shown here. Okay, so this is what happened when our hair wet. This makes our hair stick together. They are stick together because of the presence of water. So when water in between the hair molecules, so the protein from one hair, okay, will create a hydrogen bond with water here. So another protein molecule from another hair will form hydrogen bond with the water at the center. So they will stick together. Have you ever come across the problem of turning pages of book where the page stick together? Okay, to overcome this problem, you lick your finger before turning the pages. Why is it so? Because on paper there are cellulose in paper. So cellulose consists of hydrogen, and that hydrogen is bonded to a more electronegative atom, which is oxygen. Okay, this one. So this hydrogen is able to form hydrogen bond with other water molecules. So when we lick our finger will have water molecule here. So the water molecule will form hydrogen bond with hydrogen from the cellulose of the paper. Okay, so because of that, paper will stick to the finger. Alright, now we see why hydrogen fluoride can form hydrogen bond among its molecule. Thus hydrogen chloride is able to do the same. Okay, what is hydrogen fluoride? HF. If we see hydrogen fluoride, fluorine is more electronegative. Okay, hydrogen here is electronegative, so it's slightly positive. When another HF, which is hydrogen fluoride, will come, alright, so HF here. So this is slightly negative, this one is slightly positive. So hydrogen bond can form between these two molecules. But does hydrogen chloride able to do so? Let's see. Hydrogen chloride, if we refer to their electronegativity, we will say yes, they can form hydrogen bond between the molecules, but then we look at the electron density. Okay, when we see the hydrogen chloride molecules, it just like similar to hydrogen fluoride. But then, what does make them differ to each other? The electron negativity in terms of electron density. Okay, electron density. What is meant by electron density? Electron density means the probability for the electron to be found in certain place in the atom. So, what the difference between chlorine and fluorine? As we know, fluorine is just above chlorine in the periodic table. So, as we go down the group, the atomic size will increase. So, chlorine atom is larger than fluorine atom. So, what does it mean? The electron density in fluorine is higher than in chlorine. We can say that the electron negativity of chlorine is not that significant for the hydrogen bond to occur. Also because of the electron density. So that's why hydrogen chloride is not able to form hydrogen bond like hydrogen fluoride. So that's the answer for that question. So how does the formation of hydrogen bond affects the physical properties of the substances? Alright, so for this one, as we know, substances has their own melting and boiling point. For these properties, how does the hydrogen bond affect this kind of properties is that it will enhance or increase the melting and boiling point of the substance. Why? Because as we know, for melting process, let we see how the substance melt. Okay. So we start with solid. So the particle is kind of like this. The atoms supposedly same sizes. So when the substance want to melt, what happen is that we supply heat energy. So heat energy will overcome the forces between the particle here. So we illustrate layer by layer. So that's why after when it become liquid, so liquid will be like this one. It just become not in orderly manner. Alright. So when the hydrogen bond exists in the substance, more heat energy required to overcome the additional attraction. Okay. So that's why substance that form hydrogen bond among themselves, their melting and boiling point is a little bit different from the other molecules. For example, ethanol. Ethanol, its melting and boiling point is quite higher as compared to the other alcohol by comparison. Another properties that affected by the presence of hydrogen bond is solubility of a substance. For example, here is we have ethanol here. Alright, ethanol, as we know, ethanol is a non-hydrocarbon, which is organic molecules, organic compounds. So we know that organic compound just soluble in organic solvent. But then why ethanol is soluble in water? Because of its ability to form hydrogen bond with water. How it happened? So this is the ethanol molecule. Okay, this is ethanol molecule, and we know alcohol has the hydroxyl group here. So hydrogen here is slightly positive because it is attached to the more electronegative atom, which is oxygen. So what it able to do is hydrogen can form hydrogen bond with oxygen from the other water molecule. Okay, so this is the hydrogen bond, and the oxygen which is slightly negative here is able to form hydrogen bond with hydrogen atom from other water molecule here. Okay, so this is what we call hydrogen bond. Alright, don't ever confuse with van der Waals forces of attraction, because once we say van der Waals mean the intermolecular forces between molecules. So let's say we have molecules of ethanol. This is the other molecule of ethanol. The forces between these molecules is called van der Waals forces. Okay, that's all for today.